Jai Hind viewers, we come back to you again today for another interview on our completion of 1 year of our forums with one of our very eminent members who has joined us recently. Commodore Samaddar graduated from IIT Roorkee in 1978. He began his career as an engineer training with Tata Consulting Engineers, Mumbai. After being commissioned into the Indian Navy in 1980, he held various staff appointments and commanded 4 warships before taking an early retirement in 2009 in the highly prestigious appointment of Principal Director, Naval Plans, Naval Headquarters, New Delhi, responsible for acquisition, infrastructure, and budget of the Indian Navy. He is an alumnus of United Nations University, Tokyo, prestigious National Institution of Defense Studies, Tokyo, and University of Madras, Chennai. He was the member secretary of the Niti Aayog Task Force on drafting India's first comprehensive national maritime policy. He also drafted India's first comprehensive and integrated national material recycling policy. So, Sujit, the first thing which I will say to you is this, that when we started this platform 1 year back, and we were hoping that it will grow in some manner. And so your joining this platform has really, proven that, yes, the platform has some sort of a basis on which it is growing. So you have recently joined us, so you have, participated in discussions. So may I request you to give your initial impressions or your impressions of the platform as it is, MRO Digest Forums. Sujit, please.
Thank you very much for your kind words of introduction. I've just been fortunate in my life to be guided by the right people in availing different opportunities. So in that context, I think this particular forum provides me that same another opportunity. And I'm sure it offers the same opportunity for all our members here who believe that learning is a continuous process. And learning is best achieved when we discuss with our colleagues, with our fraternity, and explore the kind of thing that they are doing. And from there, we take away those critical points that particularly interest us. Now, first of all, congratulations are highly in order for completing 1 year of this marvelous exercise. There's been a huge learning experience, and I'm sure some of the articles that have been written and circulated and the interviews that you've done on YouTube has generated lots of interesting thought processes in industry, in government. I'm not very clear about how much of the academia has listened in, but my endeavor would be to try and rope them in as well over the next year, so that we have a truly multifaceted approach towards the very critical issue of maintenance, repair, and overall. So from that perspective, I think we are doing great, and there are some new ideas that have emerged to take this forum forward. I support them, but I think it would be nice if we can have a longer town hall meeting. That's something that I learned there. It's called a town hall meeting, where we have everybody in and everybody gets 2 minutes to say whatever he has to say, but exactly 2 minutes. And so if all of us think of a town hall meeting, put everybody together on one platform, and we have 4 or 3 issues to primarily focus on, and it should be outcome driven. The town hall meeting should deliver a very focused result, something that the organization can push up to the relevant stakeholders, people in government, people in industry, people in academia, in R&D institutions, wherever, so that the condensed wisdom of our fraternity is available to people who can action them. We have to admit to the fact that we are somewhat have been guys, right? So our decision making ability or steering those things are somewhat limited. It's ultimately the right people who are younger, who are more energetic, and who are more involved in this process. It's their turn to carry the baton, so to speak. And our contribution can only be to share the wisdom, the knowledge, the experience that we have gained in our lives, so that our younger generation doesn't have to go through this whole process ab initio, and they can build on our wisdom, on our experience and our knowledge and everything else that we've got, and we just pass this on to them. So that is my sort of vision of where MRO could be headed over the next year, and I'll be very happy to join this endeavor. But you can let me know. I think we can speak a little more about how the MRO scenario is and what new technologies can be there in it, etc. We can discuss that if time permits.
Yeah. Well, thank you very much for that. Actually, what you just said, is indeed what is the overall direct aim of this whole forum. And you mentioned that the younger generation, and you also mentioned that the collective wisdom. In fact, that's the very reason for bringing this about, because there was a feeling which I mentioned earlier also, that there is no such forum which is looking at this professional aspect, and especially though there are in for aviation there are, but for land systems and marine systems must be something I'm not aware. But land systems I couldn't see much, and as we grew in service, I found that as more systems came in, there was a requirement of change the direction of the way we handled MRO in service. So that's something which is now possible, because we are now veterans, and with so many years of experience, when we come together, I think we can really bring out some points which can help the next generation. And I have a feeling that the country is now moving forward as far as the defense industrial base and overall industrial base in a more sure-footed manner. I remember that as we grew in service, that initially there used to be a lot of dependence on everything coming from outside, and now you find more and more. And I will share with you an experience which I had. You see, as a young man, I was tasked to retrofit a T-72 engine in the Vijayant, and that was a tall order, and the results which came were unexpectedly better than what I thought. But I had come back from my master's from the Royal Military College of Science, Shubhanam, that time, and the theory I used from there, but the actual practical knowledge was what we were taught in MCEME on equipment, because without knowing the equipment, you can't handle it. So it got together, and I'll share a very interesting thing which happened. See what happened. Typically in India, there is a issue of the engine overheating of tanks because of deserts. And so in this case, I decided that the T-72 fans were there. A particular type of fan is there. So I decided that instead of mounting one, I'll mount two. And this configuration was entirely ours. So I decided to go in for a hydraulic drive. So I'm telling you about academia, industry thing, which it's a very small example, but so I remember that there was I had to make a gearbox had to be designed, a small gearbox for taking off the drive from somewhere and putting it into this hydraulic motor. Obviously, hydraulic motor which was needed to drive these fans. So I went to my professor who taught us a degree engineering in MCME, Professor John Sundar Rao, whom I later on, when I was there, Commandant, I requested him to join me for a cup of tea. A very fine person, and he designed this gearbox. We got it manufactured and then we fitted it there, and it worked. And then the hydraulics. So what now? The second issue which came was that we had to give the drive at the other end. We had the first, we gave the drive to the pump, the hydraulic pump, by the gearbox which was designed. And then we had to, on the other end, drive two fans. So in hydraulics, it becomes easier. So now, how do you get those hoses? No. So what we did was we went to, it was being, this particular exercise was happening here in Delhi. And so we went to Mayapuri. And we went to the people who were doing, hydraulics. Right. And they said, "Sab bana denge." This is the type of people we have. Right. So okay, the hoses were a little more bulkier than expected and all that, but they worked. And all the things that happened. Now the final thing which came was the drive to the fans had to be given through a coupling, right? And this was a splined thing which was needed, and I was wondering how to get this spline thing done. So I found somebody who was doing innovation. So I went to the gentleman and I requested, I said, can you do this? We'll do it.
Mm.
You know what he gave me? He gave me a Teflon coupling.
Wow.
We just made attached it to the motor, the one end, splines on one end, splines on the other, and put this coupling through, and it worked beautifully. It never broke down, that Teflon coupling. So you see, this is what happens if you step out of your comfort zone, if you are not looking at everything to be thought through right to the T before you even start putting the first piece on the lathe or the CNC machine to cut. You just have to forge ahead and things start solving each other. And the thing which is the innovation which is there in our country is so huge. But I think there was some lack of confidence which I perceived. Till the time we have this drawing or that drawing, so many things can be done. Of course, many issues come like metallurgy. We had to get hold of EN36, EN24 steels and all that. So that happened. But that was the thing. And what I saw was when I went for this master's, and I'm talking back in 1986, is exactly what is now being talked about. You see, over there, I found that a lot of people who were coming into the teaching line who had actually been in the industry.
Right.
So, and I found that the type of lectures that they were delivering were very different. Like for example, tires. Tires is in a vehicle is more of an art than a science. Think it's like looking very nice, those sights and all that. But actually, it's more of an art and science. Just like the Coca-Cola people keep their recipe for their Coca-Cola very very deep safe. Nobody knows about it. That's exactly what the tire people do. Because it's such an amalgam of this and that, and eventually you get it right, and that's that. And you give some nice looking sipes. All the sipes do the same thing. The design is, I think, more of a good looks good, but it's to the same thing. But the real stuff is the secret. So when somebody comes in from the industry, they give you these little touches in the teaching, which make you industry ready in more way, and you become slightly better. So it's not like knowing the theory in great detail and being able to say it backwards. It is how to use it in industry and get a result. So that's what I saw was happening in the European universities. Now the aspect of research comes in, and I also found that live research was happening. In fact, I remember we were studying the suspension that time, and so we started putting piezoelectric sensors on the suspension to get the vibrations. So, these sort of things are happening, and we actually did it in a project. And I'm talking about 1986. We had a small computer which would come through, and then we would look at it, and it made a lot of difference.
Yes.
And subsequently, when I came to MCME and I was an instructor, I tried to bring in some of this stuff. It was like amazing, like brake system design. I actually took them forward wheel lock, rear wheel lock. I took people to a sandy, gravelly patch, and I told them what happens in a basically if you go for a forward wheel, if you go for a forward wheel or a tail wheel lock, the vehicle will spin in one of the situations. So I showed them how it spins and why it is important. And so this example of a dart, like if you put a rear wheel lock, what will happen is the vehicle will swing around. So these systems are designed like that. So the practical aspect was taught. So it made it very interesting also, the lecture. Otherwise, you could have always taught the brake diagram and the theory and tested it, and they would have never realized what it actually happens. So now I feel that this actual divide between academia and industry is not still fully bridged. Even later in service, I found that when I used to ask the people in academia, why don't you just convert this into an actual working thing and give it to us? Because you tell us this is possible, we will do it, but we don't have the time for that. We want something ready which we can plug and play type of thing. But that was a little bit outside their area of comfort. I would say comfort zone. But now there's very good news which has come. Two things. One is the professor of practice. I totally feel that it's amazing, and that's the way, because that brings in industry people, experience ready into the academia. And this National Research Foundation I'm very excited with this.
Yeah.
So I have a feeling that if we can capitalize on these policies, the government can give policies, but people have to work on them. And even I don't know, this is the question I want to put to you, but though it's like jumping the gun a little bit, because we are having a panel discussion on this very subject. but doesn't matter. We can, I think, discuss this here. Is that, in your view, how is it that our forum, with our experience, especially you, Brigadier YVR Vijay, who had, spent both within the defense and outside and been in educational institutions everywhere. How can we help in somehow in bridging this gap between academia and industry and policy also, I would say, somehow, and especially now since we have this wonderful National Research Foundation with us with actual committed funds. So could you throw some light on that?
Very, first of all, very fascinating listening to the examples you quoted. So let me just give you two examples that will drive home the point about how we can use the National Research Fund and also the other funds that are there to get this MRO organization really ticking. Frankly, in India, it's not ticking for a variety of reasons. Some of them are technical, but there are many other things which are a matter of governance. My first example was I was a corvette captain. Corvettes are not supposed to hang around at slow speed and all that. So, my predecessor, God bless him, he had to leave urgently, and I was left with a ship which has only had half a shaft instead of two. So we managed to get it right, and that was off Parakram time. So I was in the dry dock. So all the other ships were supported by me. You want my aid, you take it, go and fight your battle. So when I finished all this, and then the ship came out after a so-called refit that we spoke about, I could not do more than 7 knots. So I asked this guy, what is the hassle? He says the engine is surging. So I said, let me go back to basics. And that is the point that I'm saying, that that the skill or the sign of a good engineer is the ability of that person to find a practical solution to a problem. There is nothing more practical in life than an engineer. Everything that we do is practical. And it's, the theory supports it. But, if you can't convert that theory into something useful practically, which is what we'll talk about in the research fund, it won't work. So I went back to the books. I said, look, guys, I'm telling you, please, in this whole round robin of this part being sent to this ship and that part being sent to this ship, somebody else's governor coming, somebody else's gearbox coming. So I had a hodgepodge of my whole machinery system. I said, the first thing that you need to do is get the governor calibrated with the engine. And, there's a test pen, test it out. Nobody is willing to do it. And at that time, they didn't know that I was among the few commanding officers. I think probably the only commanding officer in an executive position who was an engineer from rookie. So fortunately, my engineer officer knew that. So I told him, either come here, I'll tell you what you need to do. He's a youngster. So I said, I'm not teaching you your engineering, but I'll tell you. I said, get this damn thing calibrated and we'll be okay. Because you've got a mismatch between your input stream of fuel and your input stream of air, and that mixture is not working well. That's why you're surging. So it didn't happen. So then I had to go and meet my CNC, who was very grand, who told me, you just go ahead and do whatever you want. So I went off, and then I had an opportunity where I spent $40,000 from my pocket. I was in Chennai. They had an excellent lab there where they calibrate the governor. So I told my engineer officer, chupchap jaake, get this governor calibrated, and I will hold on a sailing signal if I get. I mean, if the governor is out of the ship, if I get a sailing signal, I'll be, buried on the spot. So for background work, I managed to evade a sailing signal, but I told him that you've got 24 hours. Your 24 hours starts now. You buzz off, do what you want, but get it back. I know this will work. So he went and did it. And sure enough, when he came back, the thing didn't work. Right. So I said, kya hua? He said, dekhta hu sir. So I was back again to 6 knots. Then I told him, just do a functional basic check, tick mark all of them. And sure enough, the mistake was found out. The air pipe and the fuel pipe had got mixed up in 2 places. So when we came out, we did 24 knots. And after that, I never stepped back. And I made a personal signal to my CNC. I just said, achieve 24 knots. So, this is what can work. So whilst the maintenance and repair organization did a particular sort of thing very mechanically, thick kar do, lube oil kar do, wall change kar do, ye kar do. But the basics of engineering, of being able to get the right graphs, ultimately everything is on tables and graphs and performance. So unless you got all these things in front of you, you can't detect what has gone wrong. So this was one example. The second was an even simpler thing. When I was commanding the frigate, I had 2 torpedo tube launchers, right? That's a vital thing for a ASW frigate. If my torpedo tube launcher doesn't work, then I might as well, uh, make my coffin and go down with the ship. So I was very keen that this damn thing worked. And this was made by a private Indian company who gave me 100 solutions. It didn't work. I had no clue about this, frankly. I had no very clue. And finally, there was one exactly like you did. You found somebody in Mayapuri. I found somebody in Kurla. I think it was or Bindi Bazar. That guy. He came on board. I said, "Yeah, ये केबल है. Please make this. इसका नकल बना के दे दूँगा." He said, "ये होगा, वो होगा." I called my supply chain. इसका कैसे हिसाब कर सकते हैं? ऐसे कर दो. So he took this cable and without taking all those 100 quality checks and quality assurance and this and that and all these 100 things, we took this cable and nakal bana ke dal diya. So we tested it out. Of course, I can't test it with a live torpedo, but we tested on the simulator. So it came back online. So my electrical officer did a wonderful job of it. I mean, he actually was on hand. I was not an electrical guy, so I didn't know, all this stuff about kaun sa meter kahan pe. So these two things are there. Just to give you a background on how this interface between theoretical knowledge and practical experience is so meshed. Unless you understand the principles, you will never be able to successfully implement it practically. This is my sort of take. As regards the funds, I think I think some discussion has taken place. If we can bring ourselves to be an association with a slightly research-oriented MOA sort of thing, then within us we can start bidding for smaller projects. It is open to everybody. I'm just saying, for example, fuel oil filters. I'm just giving you an example. We got a fuel oil filter on aircrafts, we got fuel oil filters on ships, we got fuel oil filters on tanks, 100 places we got this damn fuel oil filter. And this fuel oil filter has a life, whatever it is. It has to be replaced after so and so years, etc. I'm just saying, suppose we make this the fuel oil filter and the lube oil filter. The lube oil filter is more critical to me because if the lube oil doesn't work correctly, then you will just have an engine seizure and you're finished. At least fuel oil filter band ho gaya, to chalo, you might get a what's the word for it? I forget the word. When the fuel stops, airlock. You might get an airlock. But at least if the fuel lube oil doesn't work, then I'll get an engine seizure and then I can say goodbye to my career or whatever else in the day. So lube oil filters must work. So is it possible to look at the kind of materials that we are using for lube oil filters today? The kind of mesh designs that we are making? What should be the engineering design that has to go into it? At the moment, a standard filter is a cylindrical cone, is a cylindrical thing. But can we make it conical? Because you need to balance two things with it. The mass flow has to be maintained so that the heat transfer, etc., takes place on the one side. Secondly, the pressure, which is a function of the volume that will pass through it, has to be maintained. Ultimately, the purpose of lube oil is a heat transfer funda. So unless if you get that heat transfer right through better lubrication and consistently, you could do it. Why I'm saying this is something that we are designing for desalination plants in some other work that we are doing, where we're looking at a novel filtration system which is not cylindrical or not planar but conical. So where the cone is at the center. So using normal fluid mechanics, you can understand this. And there's a lot of boundary layer issues which come up, so that the velocity of the thing remains good, and you're able to maintain a certain amount of fluid flow at a certain pressure, which will give this. So this is one example. We can look at hundreds of things there, the expertise that we've got. And if we put our minds together and put up a nice proposal let's not try and put up a proposal to make the 7th generation fighter aircraft. Wo nahi kar sakte. But we can make some smaller things. For example, another project that we are working on is radar absorbent metamaterials. That's something that I'm working on, where we are working with IIT Delhi. So they did a lot of tests for us with NTU Singapore and with what's its name, Electromech in the US, who have done our tests on these materials. Now we are doing in the design engineering phase to see how this metamaterials can replace coatings to get a lower stealth signature on submarines and aircraft. It's very fascinating. Now, smaller projects like this, I'm saying, can be maybe up our sleeve to experiment and work on. So at some forum, maybe we can discuss this in length. and see, maybe take up 3-4 projects, make a nice proposal. Don't spend too much money, 5-6 crores, 8 crores, 10 crores. So then nobody bats an eyelid. Provided we have an organization, the team is right in place, we have the NABLs to support us, or the IITs or whatever else, we can do that. So I would suggest that we can actually make a contribution to our country in many of these things by uh, by maybe participating in some of the IDEX challenges ourselves, maybe participating in some of the make two projects ourselves. Let's try and do that. Maybe you can benefit from it. We might find some funding support or something. A little ambitious, but I just thought I would sound my heart out. That may be useful to you.
Thank you for that. In fact, what you just said, actually, there are so many thoughts in my mind. We can carry on discussion for the whole day. But we will do this. I think this is you what you said actually is for the first time showing me a place. What happens is that academia now doing even a engineering degree is taxing, and a lot of, and even for the teachers it is taxing, and even if at a higher level also, you say at master's level also, it's quite taxing. And so everybody is actually focused on at the end of the day, that degree, and picking up a job, because that's what it's all about. But so everybody's sort of fully resources are being utilized. On the other hand, we are people who have these degrees and who have been working and all that, like this excellent thing you talked about, fuel oil filter. If you can have a better mesh, it just solves so many problems. So that's directly a research oriented with, let's say, a very bright IIT student who's looking at meshes, materials, the new materials which are coming out. They are having the machinery, they are having the test equipment, they can do the research, they can do the mathematics of it, everything they can do. They have the computers in the institutions to simulate it. I'll give you an example that when I went for my master's, at that time the computers had just come about, and they used to do, I was doing, of course, military vehicle technology. So we did use, but they used to have these huge computers those days, which used to completely fill a room. And they used to do finite element analysis on the ordnance, on the barrels.
Right.
So the whole, when they did finite, because finite element analysis, everything had to be, the whole design had to be checked. So the computer used to be not available to anybody else for almost 24 hours when it was crunching those numbers. Those days computers were like
4 4.
Yeah, no. So but now it can happen in a jiffy. So there's so much possible. So I think maybe this is a place where we can offer our services, because we are just trying to help, isn't it? And you are in touch with people. So I'm sure within our group there will be people who can at least like a sort of a sounding board to a guide of a student who's doing a project which is practical oriented. We could have some people here who have done something in service, and they can guide a little bit. So maybe that's an area which we can step into. But anyway, as I said, we could carry on and on. But for today, this being just marking our 1 year with MRO forums. Now, if you could just summarize, you have already mentioned your specific areas where you feel that we can really work towards in the coming year. Sujeet, please.
So I think by and large, as I said, we are actually an equivalent of a AD converter, analog digital converter. So which means that only thing, we are not a analog digital converter. We are a knowledge experience converter to an output, which we can bring in. All of us have faced problem statements. I gave you the example of governors, data cables, this, that. You also may be having 150 of them in your life. So maybe we can select some of those problem statements which are genuine, which come from a practical perspective. Let's take 3, 4, whatever, aviation or something else, wherever we feel safe. Corroborate the same problem statement, whether it's been solved or not. Pata chala ki it's already solved, and we are again, cracking our heads on something which is a solved situation. And it's also quite possible that the service may be accosted with that problem, but don't think it is of significant concern. So that is one. Secondly, over a period of time, I have now been interacting with quite a lot of these institutions, academic guys. They are good. There are a lot of opportunities there for postdoc studies. They have PhD scholars who are working with them, and they also have postdoc guys. So the postdoc guys are extremely focused fellow. So if we have a very focused statement, problem of the statement, like a PhD thesis with a hypothesis and a null hypothesis as a problem statement, very simply written, that this is my hypothesis and this is the null hypothesis. Now you go and find out whatever it is. I'm not saying that design this or that, but these are all related to fundamental research. PhD chairs should be doing fundamental research, not so much of applied research. So maybe we can look at that. Third, of course, is one way of we got a tremendous amount of talent here, lots of experience here. Let's see how we can start bucketing them in some interesting ways, so that smaller task groups can be set up within the organization itself, and we can form subgroups and meet over a cup of coffee at DSOI or God knows where, or Kota House or somewhere, and also have a chat. And of course, the virtual forum is very, very productive and useful. So these are some initial thoughts. I will take it from there. Thank you very much, really, for this opportunity.
Yeah, thank you. In fact, the word refreshing again comes to mind, which I had mentioned. It's very refreshing talking to you, and I think we're much richer by your having come to. And I thank General Amarjit for introducing you to our forum.
Thank you.
General Amarjit and I go back a long time. Yeah,
I see.
So it's wonderful to have you with us here.
Yeah. Thank you so much. Read mind completely.
Yeah. So I would have liked to carry on, but viewers, with that interaction, now I thank the viewers for being with us, listening to us. The links to Commodore Samaddar's LinkedIn profile is there in the show notes below, and you are welcome to get in touch with him if you want to, if any of what we have talked about interests you. And if you find our material interesting, do subscribe to us. We look forward to having you back, our future videos. And we are essentially a platform for MRO professionals. And so all MRO professionals, no matter where from the defense or civil, anywhere, are welcome to be a part of our platform. It's free of charge. There's no subscription. So we look forward to more of you joining us. And now, once again, after thanking Commodore Samaddar for an excellent and a wonderful and a refreshing discussion, I'll bring this particular interaction to an end. Thank you. Thank you, viewers. Jai Hind.
Jai Hind.